Okay, very good morning. So you are joined to mineral economics lecture series, and so let's see what is the mineral economics. Okay, and so I try to find what is mineral economics and what is its important. So when we are searching, in last semester you studied geophysics, so you can find some job position as geophysics, and last year you studied geochemistry, so you can find some job position as a geochemist, and you studied mineralogy and you can find some jobs as mineralogist. But when we consider about the mineral economics, so it's quite difficult to find exact job as a mineral economist. Probably, so it's a subject in the academic field. It's a subject in the academic field, and most of these concept and these what we learn here, so you have to apply so when you enter the administrative level. So therefore if you join some industry in future as some kind of administrative position like management training or some kind of senior mining person in the particular site, so you have to apply those principles and theories what we learned in this course. Okay, and therefore this is really important. So when you enter the administrative level. Okay, so this is the definition for the mineral economist, as I mentioned earlier. So it's an academic discipline. So in the industry it's quite difficult to identify the exact job as the mineral economist. There are some, but it's quite rare because normally it's come or it's appear with some with your experience or with your some position like in the administrative level. So mineral economist is the academic discipline, and it investigates and it promotes understanding of economic and policy issues associated with the production and use of mineral commodities. So as this definition says, so it's really associated with some kind of decision taking condition. So that's mean it's really associated with some kind of administrative level. Okay, so in the mineral economics is the academic discipline, so it's investigate and promote understanding of economic and policy issues associated with the production and use of the mineral commodities. Okay, so therefore this is the academic discipline, but it's really important. So taking some kind of decision at the administrative level. Another important point I need to highlight here, that is most of the management level or owners of the mineral deposits in Sri Lanka are really have some kind of subject-based experience. So they are not expert in the subject wise. So therefore, so you make some kind of bridge between the laborers and owners through this kind of linkage. So therefore, this is really important. So when you are enter the industry. Okay, so let's see what is the mineral exploitation or mining. So it's really simple thing. So this is the extraction of valuable mineral or mineral resources or other geological materials in the profit way from the earth. Yes, you know, in this course, most of the things you have already learned. So I will summarize that thing here. And in mineral exploitation, or other words in mining, so that is some kind of extraction of valuable minerals or mineral resources from the geological materials in the profitable way. Okay, the term profitable way is really important because we can extract some kind of minerals, but most of the minerals are not profitable way. So therefore, we have to be very careful. Uh, this is some kind of business. So business main target is the profit. So if there is no any profit, so investors or particular person not will invest money in the particular mineral commodity. So therefore, profit is the one of the key parameter. So therefore, mineral exploitation is the extraction of valuable minerals or mineral resources or other geological materials in the profitable way from the earth. So I will take some a simple example, and that is from magnetite deposits in Buttala. Okay, so I took some example, that is the magnetic deposit from Buttala, and so yes, there is a mineral deposit, that is the magnetic deposit in Buttala. So that is the question. So whether we can extract magnetite from particular deposits in the profitable way, So this is the main question what we have at the moment. So we have some kind of deposits there. So when we extract the money, so when we extract that particular mineral commodity from the particular deposit, so we have some question whether this particular mineral deposits can we exploit in the profitable way. So that's the main question what we have at the moment. The reason is, so during the exploitation, so we have to spend some money, and if we calculate that expenditure money, that is quite similar to or quite equal to the profit. So that's why that is the main issue of the particular mineral deposit. So therefore, in the mineral exploitation, so we mainly consider the profit. So this is one good example, that is Buttala magnetite deposit. The reason is the expenditure is almost equal to the profit what we expect. So therefore, there is a huge risk to invest money for that kind of deposit. Okay, and mineral exploitation or mining is money making business. Yes, the investor, they need money, and not only mining company or the owner, but government also make a money from the revenue. So because government should have some kind of portion as a taxes. So therefore, this kind of business is really important for the government, because this is the one of the way government earns some kind of money. And even so workers receive income, and therefore this kind of mineral industry has some kind of benefits, not only the owner but also government as well as workers. So therefore this kind of a linkage is required, so all will get the benefits for this kind of mineral deposits. So this is the simplified world mining map. So actually, this is one of, I took this map from one kind of book. So I will share that book with you later. And so these are the map, what we can see, world mining map. So you can see the different kind of minerals here: iron, tin, copper, zinc, nickel, chromium, magnesium, manganese, aluminium. So these are the different deposits are located on the world map. And so this is the another map. So actually I prepared this map, and I and one of my student, and so these are the heavy minerals map in the world. Actually we refer the very large database from the USGS, because we identified that there is no recent up-to-date map. So therefore we prepared this map, and this is the map of for the heavy minerals, and this is just for your reference. So you can see the mineral deposits are distributed everywhere in the world. So and this is the same deposits based on its origin. So origin can be igneous, it can be metamorphic, or it can be sedimentary deposits. In addition, we can further divide as a hydrothermal or surface deposit. So this is some kind of simple classification of these heavy mineral deposits in the world. Okay, so in previous map, you identified that. So most of the mineral deposits are distributed many places in the world. And then if we are talking about the usage of the minerals, so I think you are very familiar with this thing. And yes, And minerals are used from very primitive application to very advanced application. So I need to highlight that point. And so minerals are used in a very primitive application to very modern or very advanced application. So these are some example. So you can see in here age, different ages and different uses and for different kind of mineral resources. So these are the different kind of mineral resources, and these are the usages and during the different time period, even the prehistorical medias. So that's mean before what we know our history. For example, so some very ancient people, so they use this some kind of mineral resources as tool, as weapon for hunting and defense, and so they use some kind of minerals as food and shelters. So during the prehistorical periods, in the ancient times, people used minerals as jewelry or ornament. And early stage, they in the human civilization, so they use the minerals to prepare currency and some structural devices. And so later they use some kind of mineral resources for the energy. And the modern day, we all know minerals used for the different kind of application like machines, electronics, and nuclear reactions. So therefore, minerals have wide application from very primitive to very advanced or very modern application, from prehistorical period to the modern scales. Okay, and so this slides shows so minerals has wide kind of application from the prehistorical period to the modern time. Okay, and I noticed that some t-shirts you prepared MRT, one of the MRT batch. So in this t-shirt you mentioned pre-lithic or something like that, and some kind of praise in that t-shirt. So that t-shirt, that praise also mentioned same things, minerals used from the very historical time to the modern applications. Okay. Okay, when we are talking about the mineral economics, so we have to familiar with three terms. We have to familiar with three terms, that is ore, gangue, and waste. Okay, so these three terms are really important to get some idea about the what is the mineral deposits. And first is the ore, gangue, and waste. Ore can be defined as occurrence of rock or sediments that contain sufficient minerals with economically important element, typically metals that can be economically extracted from the deposits. I think this definition is very familiar with you. So remember, so I will not ask what is the definition for the ore in your exam. So I will not ask, because now we are in the fourth year. So you have to think something in, you have to analyze something, you have to discuss something, you have to critically think something. So these are the very primitive, therefore I will not ask some primitive definition in your exam. And O, this is the definition, but you have some idea about the what is the O. O can be defined as occurrence of rock or sediment uh, that contains sufficient mineral with economically important element, typically metal that can be economically extracted from the deposit. So therefore, O mean what kind, typically it's a metal, so which can be extracted from the deposits in the economical way. So therefore, we can simply say ore is typically metal, so that can be extracted from the particular deposits in the economically way. So in the economically way, so this is the main key points for the ore. So then what is the gangue? So gangue is simply we can say, so it's a valueless mineral particles within the ore deposits. So we can say it's a valueless mineral particles within the ore deposits. So therefore, we have to remove gangue from the ore minerals. We have to remove gangue from the ore minerals. Okay, then what is the waste? So there is some kind of difference between gangue and waste. So today I will explain it very exactly. So then what is the waste? So we can define waste as material associated with an ore deposit that must be mined to get at ore and must then be discarded. So gangue is the particular type of the waste. So therefore, let's see what is the difference between the gangue and the waste. So gangue is some kind of waste. So waste we can define as, so we have to remove some kind of material to get the ore. So this part we call the waste. Okay, so I think it's not exactly clear for you. So therefore I will take some example. I will take some example. So I will take some example from quarry deposit in the Aruvakalu. I will take an example that is the quarry deposits from the Aruvakalu. Okay, so in the Aruvakalu, we take calcium carbonate. We take a calcium carbonate. It is important for the raw material for the cement manufacturing. Cement manufacturing. So this is therefore we can say that calcium carbonate are the ore material of the Aruvakalu deposits. So in this Aruvakalu deposits, so you can see about 10-meter thick red dirt. You can see the 10-meter thick red dirt. So in this red dirt, so we can consider as a gangue. We can consider the gangue. So it's not a valueless mineral particles. Okay, and that one also considers the waste because okay. I try to find some good photo, but anyway, it's not available at the moment. Therefore, I will draw. It's fine to find this space. So, okay. So you can see some layer. Okay. So this is the calcium carbonate. So this is the raw material what we need. Okay. So this raw material is covered by some weathered calcium carbonate layer. So this is the weathered calcium carbonate layer, and then after that red dirt. So this red dirt is about 10-meter in thickness. Okay, R is denoted for the red dirt. Okay, so this red dirt is about 10-meter in thickness. So if we need to take this calcium carbonate from the deposit, so we need to remove this red dirt. So therefore, this red earth is a part of the gangue mineral. So this is red earth is the part of the gangue mineral. So it's underlaid by weathered calcium carbonate. So we have to remove these weathered particles, weathered calcium carbonate, to get some pure calcium carbonate, because this is mixed with the sands and this is mixed with the sand. So therefore it's not suitable for the cement manufacturing. So therefore we need to get the pure calcium carbonate. So therefore we can define as a red earth and this weathered or silicon particles as a gangue minerals or gangue minerals. In addition, since we have to remove this red earth and this silicon rich weathered rock, uh, since we have to remove this red earth and weathered silicon rich rock from to obtain this calcium carbonate, so these two layers we can consider as a waste, because we must remove these two layers to take what we require. So therefore, these all things we can consider as the waste, and red earth can be considered as a gangue minerals. So the term gangue is really important because we mentioned it's the useless mineral particles. It's the useless mineral particles. Yes, with the current technology, so we have no any application of the red earth. So therefore, we can consider it as a gangue mineral. But remember, technology is upgrading day by day, and sometimes when we remove previously as the gangue minerals, so sometimes we can use with the current development of the technology. Okay, good example, this red earth. So now Australian company, that is Iluka Resources, one of the leading heavy minerals company in the world. So now they are interested to extract ilmenite from this red earth material. So in the initial stage, so we remove this red earth as the gangue minerals. Now technology is updating. So we mean Sri Lanka has no such technology, but some other foreign companies, maybe like Iluka Resources, so they have that technology. So they think so they can extract this ilmenite from this red earth material, So therefore, once gangue minerals can be ore minerals at the latest stage with the development of the technology. I think it's clear. Once gangue minerals can be ore minerals at the latest stage with the development of the technology. So, but in the waste, so waste means that we have to definitely remove to get the ore deposits. So therefore, according to the definition, so both are the waste because we have to remove this red earth and this silicon rich impurity weather drop layer to get the pure calcium carbonate. Therefore, both are the waste, but we can consider this as the uh, gangue mineral. So, but we have to remove these gangue minerals or red earth to mine calcium carbonate. But this gangue minerals, that is the red earth, can be um, in future with the development of the technology, because some companies believe so they can extract ilmenite percentage is about 3 to 4 percentage, so they think they can mine, so they can extract ilmenite from this red earth bed. Okay, I think it's clear for you. And then so let's see some kind of classification of the different mineral deposits. I think this is very familiar with you, and this is some kind of just summarizing some previous thing. And we can divide minerals into different categories like metallic ores. First one is the metallic ores. Metallic ores we can further divide ferrous metal, that is iron and magnesium rich mineral like iron, manganese, molybdenum, and the tungsten. And like base minerals, this is another subcategory. So copper, lead, zinc, and tin are example for the base metal. And precise metal, gold, silver, and platinum group metals, and radioactive minerals, uranium, thorium, and radium. So these are for just classification of the metallic ores. And non-metallic minerals, so we call it the industrial mineral. So these non-metallic minerals or industrial minerals are included phosphate, potash, halite, sulfur, construction aggregates such as sands, gravels, limestone, and many others. Okay, so these are the non-metallic minerals. So these are not metals. So therefore, we use the another terms industrial minerals like phosphate, potash, halite, sulfur, construction aggregate are some kind of example from these non-metallic minerals, or we use the common term is the industrial minerals. In addition, so we have the fossil fuels. Good examples are coal, natural gas, methanes, tar sands are good example for the fossil fuels. So this is very fundamental thing. So you are very familiar with this, and so therefore we can classify mineral commodities into mainly three categories, or it can be further divided into different stages. Okay, let's see the different type of deposits. So now we are talking about the different type of mineral deposits. I think this one also you are very familiar with. So we can see the mineral deposits, which we are called economically interested mineral deposits, into mainly three ways. First one is the ore body, like here. So we can see the whole body as a particular location. We can see the whole body as a particular location. Good example, Buttala magnetite ore body, and another example, Kaikavala, that is in Matale feldspar deposits. So these are the, and another example is uh, Arwakalu calcium carbonate deposits. So these are the ore body. So you can see, you can identify whole ore body as this as some particular area. And next, vein, good example is the vein graphite deposits in Sri Lanka. So we can see the minerals deposits as a different kind of vein. We can see the different kind of veins in this particular mineral deposits. So therefore we can find mineral deposits as a vein. And third one is the placer deposits. Minerals accumulate in special locations like Pulmude deposits and Pulmude heavy mineral deposits and garnet deposits in the Kirinda, and another one is the Verugal heavy mineral deposits. Likewise, these mineral deposits are accumulated as a placer deposits in particular locations. Okay, and that one also very clear because it's a very fundamental thing. And let's go to the next section, and different stages in the mineral processing practices. Okay, so in mineral industry, so we can divide this industry into different stage. So mainly, so we can divide mineral industry into 5 stages: prospecting, exploration, development, exploitation, that is the utilization, and reclamation. So therefore, mineral industry. So we can divide into mainly 5 stages: prospecting, exploration, development, exploitation, that is utilization, and reclamation. Okay, so I will ask a question. So I mentioned mineral industry can be divided into mainly 5 stages. So those are the stages. So from where we can get the benefit? I means the profit. What is the stage we can get the profit? Tashmina, what is the answer? So I mentioned, so mineral industry can be divided into 5 stages like prospecting, exploration, development, exploitation, that is the utilization, and the reclamation. So my question is what is the stage what we can get the profit?
Fertilization. Fertilization.
Utilization. Yes, exactly. So exact answer is the utilization or exploitation. So in the prospecting stage, so we can't get the profit. In the exploration stage, we can't get the profit. At the development stage, we can't get the profit. At the exploitation or utilization stage, we can get the profit. Even the reclamation, sometimes we can get the profit, but sometimes we can't get the profit. Okay, so I will explain that one later, not today, later. And so therefore we can get the profit at the mainly during the exploitation or utilization stage. So this is the time, so we can get the profit. So this is the time we can get the profit. But expenditure, so we have to use money during the prospecting. We have to spend money for the exploration. So we have to spend money for the development. We have to use the money for the reclamation. Yes, we have to use the money for the exploitation. So therefore, we have to spend money during these all 5 stages. We can get the profit mainly from during the exploitation, but sometimes we can get the profit even the reclamation. We can get the profit in the reclamation. So I will explain that one with some good example, real world example. So therefore, we have to spend money in this all 5 stages. We have to spend money in the all 5 stages, and mainly we can get the profit during the exploitation or utilization stage. We can get the profit. We can get the profit mainly exploitation stage. But anyway, remember, this should be greater than the all expenditure. So this should be greater than the all expenditure. So this is the expenditure, and this is the profit. So profit should be greater than the expenditure. Otherwise, so we will not get the profitable way. So otherwise, we will not need to do some kind of business. Okay. So because this is the profit based thing. So this is the profit based thing. And so therefore, every times the profit is the critical factor. So therefore, profit should be greater than the all expenditure. So you have to spend money during the prospecting, exploration, development, exploitation, that is we call utilization, and the finally reclamation. But we can get the profit mainly during the exploitation, or we call it the utilization, but sometimes during the reclamation also we can get some money. Okay, prospecting. Prospecting is the initial stage. So what is the prospecting? Prospecting is the initial stage or first stage. So prospecting means we are looking for some kind of mineral deposits. Okay, and so we are looking some new mineral deposits. Maybe we are looking some new heavy mineral deposits. Maybe we are looking for some gold deposits. We are looking for some magnetite deposits. So this is the prospecting. So this is the initial stage of the utilization of the mineral deposit. So our final target is the profit, that is the utilization. So this is the initial stage for the utilization stage. As I mentioned, this is the search for the ore or other valuable minerals. We are looking. So prospecting means we are searching or finding some particular mineral deposits. Okay. So when we are talking about the looking or prospecting or searching mineral deposits, so again, we need to do some kind of investigation. Okay. So for that one, so we can do some direct investigation or we can do an indirect investigation. For example, geological mapping, some physical sampling, so we can consider as the direct method, and geophysical method and geochemical method, so we can consider as the indirect method. I think you are very familiar with these things. Even the I have already touched those things under the mineral exploration and method. So therefore, prospecting, the time we find some mineral deposits, and this times we have to use direct method, or we have to use indirect method. So direct method means the physical method. So we have direct access to the particular mineral deposits. So it can be physical borehole logging or some kind of physical collecting samples or geological mapping, or structural mapping, indirect method, geophysical or geochemical method. Okay, when we are talking about the direct method, so these direct methods are limited to the surface deposits. For example, high-Kavala deposits, Buttala magnetite deposits, we can do direct investigation. But take a initial stage. This is we are looking for the prospect. Prospecting means that we are looking for the some kind of mineral deposit. So don't think about the current situation. Think about the very early stage of the graphite deposits in Sri Lanka. So that time there is no any ships, so there is no any tunnels. So at that time, so we can't do the direct things. Okay, and because there is no any visual examination, so therefore at that time we have to go for the indirect method. So therefore direct methods can be used for the surface deposit. For example, oil or gas deposits in Sri Lanka, we can't use the direct method because we can't go the particular deposits, we can't see it because it's in the very deep area. So at that time, so we have to use the indirect method mainly for the prospecting stage, and in the direct method, we consist of the visual examination. Okay, and that is the visual examination. So that during the prospecting. So in geological studies, and we can do the entire area if the deposit is the surface, and we can use the direct sampling, or we can apply direct technique. We can prepare geological map, we can prepare structural map, so we can collect the sample from the directly from the deposits like magnetite deposits in the Buttala. So these are the we call the prospecting using the direct method. In addition, as I mentioned earlier, so we can use the aerial photographs, we can use the geological map, the structural maps, and geologists can get some kind of evidence by observation, and this kind of direct methods are important to locate minerals deposits. Based on those collected data, so mapping is really important. I think Gayani madam has already taught you these geological mappings. So mapping is very important thing. So you can prepare geological map and structural maps, and for the particular mineral deposits. So then you can get some idea about the demarcated boundaries for the particular mineral deposit. So therefore, in the prospecting, that's the time for the we are searching for some mineral deposits. So you can prepare map in the particular area. And in addition, you can prepare geological maps, and you can do some kind of microscopic studies for to some identify some minerals, and then so you can locate particular deposits, and you can get some idea about even the hidden part. So in the surface mapping, so we can see only something related to the surface, but based on the surface geological mapping, so you can get some idea about what is the inside there. So even we can predict based on the strike and dip direction. So we can determine so extension of some kind of mineral deposits or some kind of mineral layering. So these things we can achieve during the initial part of the prospecting. However, so in the indirect methods are really important during the prospecting because we can't touch or we can't explain the whole mineral deposits only using the physical or direct method. So therefore, indirect methods are really important. So when we are talking about the indirect method, so we can apply different geophysical methods. So those geophysical methods are really important to identify the different kind of mineral deposits. So we already familiar with the different geophysical method, and you can apply those physical method to identify or locate particular mineral deposits. In the geophysics, yes, we already know anomalies are really important. Anomalies may be the high magnitude or enrichment factor, and So we can use the different geophysical method like gravity, seismic, magnetic, IP, induced polarization, and radiometric variables to identify or locate mineral deposit. So therefore, in the prospecting, anomalies are really important. So based on, we can use the different geophysical method. Based on those different geophysical method, we can use to identify some particular mineral deposits in the particular location. So this is just an example. So this is just example. So we are doing some kind of geophysical investigation, geophysical investigation. So then you can see some kind of contour lines, contour lines. So this red color line is indicates the high magnitude area, high magnitude area. So based on this kind of map, we can clearly identify, So this is the area for the ore deposits. So this is the area for the ore deposits. So based on this kind of geophysical method, so we can clearly demarcate the boundary of the ore mineral deposits. So this is the area for the ore mineral deposits. And so this is the highest anomaly area. So this is maybe a highly enriched area. The concentration of the particular minerals is highly enriched in this area. So this kind of thing we can interpret at the prospecting stage, using this kind of geophysical method. So geophysical method we can conduct as the airborne method, as a land survey. So we know, and we can use it as airborne survey. For the airborne survey, so we can use the aircraft as well as we can use the satellite images for the prospecting stage for the geophysical investigation. In addition, like here, so we can do the surface geophysical survey. And in addition, so we can collect samples during the prospecting stage. So we can use geochemistry. We can use geochemistry for the quantitative analysis. We can use the geochemistry for the quantitative analysis. Okay, so we can collect soil samples, we can collect rock samples, we can collect water samples and geobotany samples, and though we can use this kind of things, we can use this kind of sampling and for different geochemical analysis to identify the prospect. Okay, so if you remember my previous slides, in here I demarcate the boundary of the mineral deposits. Even another simple, this is not exact, we can use the some simple method uh, to identify or demarcate the boundary of the mineral deposits. That is the vegetation. So this statement is really important. Okay, I read. The analysis of plant growth patterns can also be employed as the prospecting tools. So this statement is really important. Okay, I will give some example. If you go, so some nickel or serpentinite deposits. Okay, if you go for the serpentinite deposit means is a nickel rich deposit. Okay, nickel and iron content is rich in particular deposit. Okay, so you have no any idea where is the boundary of the particular deposit. This is not the exact way, but you can use the prospecting stage. Prospecting means the initial stage. This is the initial stage. You are looking, you are searching for the mineral deposits. So in the prospecting stage, you can use this plant growth pattern to identify the boundaries of the particular mineral deposit. Okay, my example is serpentinite deposit. Okay, my example is serpentinite deposit. Okay, in the serpentinite deposit, and okay, so this is the land. Okay, this is the serpentinite deposit. Okay, so this is the serpentinite deposit. Okay, this is the land and this is the serpentinite deposit. You stand here and you work along this land. So when you enter this serpentinite body, so you can clearly identify some vegetational change. So when you leave this serpentinite body, again you can identify some vegetational change. This is really important. So this observation you can, this is not the exact way, but at the preliminary stage, at the initial stage or prospecting stage, so you can use this method to identify the boundary of the particular mineral deposit. Reason is, in here in the serpentinite, nickel and iron are rich. So therefore, so enrichment of the nickel is not suitable to grow different kind of all kind of plants. So therefore, some unique plants, so can be observed in this area. There are some unique plants. So which is associated with this kind of mineral deposits. Not for the all mineral deposits. Remember, not for the all mineral deposits, especially for some mineral deposits like serpentinite, some magnetite deposits. So you know it's a rich in the iron, and enrichment of iron is not suitable for the all type of plants. Maybe some specific plant can be observed in the particular area. Okay, so especially this kind of parameter, so we can use to identify some metals. So if you go for the serpentinite deposits in Sri Lanka, so you can see some clearly that vegetational change can be observed. So in the other areas, we can see very large plants, trees, but in the serpentinite body area, so you can see some kind of special bushes. So therefore, you can clearly see some vegetational changes. So you enter the some metal deposits. Same thing. So you can observe in Seruagila deposits. That's the copper pyrite deposit. So you can see some kind of special bushes, not like large space. So this is due to the change of the chemistry of the soil as well as the surrounding rocks. So therefore, this can be used as a good parameter at the particularly prospecting stage. Okay. Next, I go for the next stage, exploration. So exploration is the second stage. Okay, exploration is the second stage. So this is the line between prospecting and exploration is not sharp. So you can't clearly identify the boundary between the prospecting and exploration. So you can't identify the clear boundary between the prospecting and exploration. And in the exploration, our main target is to determine size and value of the particular mineral deposits, and to determine utilization techniques. Again, please move back to the prospecting stage. So in the prospecting stage, so we just identify the boundary. That's all. So we are not going to determine the size. We are not going to determine the value of the particular mineral deposits. So in the prospecting means we are searching. So this is the some kind of very preliminary stage. So this is now we are moving quite advanced stage. So now we are moving to quite advanced stage. So that is the second stage in the exploration. So our main target is to determine the size and value of the mineral deposits, and to determine utilization technique for the accurately as much as possible. So in this stage, so we have to do some kind of accurate estimation. In the previous stage also, we can determine the size of the particular deposit. Maybe this deposit is located about 1 kilometer. Likewise, we can do the preliminary size estimation at the prospecting stage. But in here, so we need to determine the accurately as much as possible. And during the exploration stage, so we need to take the exploration license. Okay. For the mineral searching, you don't need any exploration license. During the identify some mineral, heavy mineral deposits, so you don't need any license. So you can go to the field, so you can do some kind of preliminary investigation, and you can determine the boundary and other things during the prospecting. But during the exploration, so you need to get the exploration license. So exploration license grants the license holder the exclusive rights to explore for the all mineral categories authorized by the license. So in the license, so it's mentioned the particular owner have rights to explore gold, maybe quartz, maybe feldspar in the particular area. So therefore, exploration license is very important. So later, not today, so we will discuss how to take exploration license. So during the exploration, so we can collect the samples. We can collect the chip samples from the outcrops. This is the common way. And we can do the trench, and it's a long and narrow ditch. So using the trench, you can collect the samples. You can have a tunnel, or you can have a auger or drilling samples. Okay, so you can collect the different sample methods. So this one also I already taught you in mineral exploration and method. And we can collect samples from the borehole, and in the borehole logs provide valuable information. Yes, I already taught that part. So I gave some example for the different kind of borehole logging, which we use industry and like CECB, and using that borehole logging. So you can locate some kind of some kind of mineral, get some idea about the mineral deposit, and we can apply those borehole logging data with the geological mapping or structural mapping. So in the exploration stage, in simply I can mention, so we collect the samples, chip sample, trench, tunnel or drilling sample, and we may have some kind of borehole logging data. So we try to get some exact idea about the size and value of the particular mineral deposits and the utilization techniques. And in addition, in the exploration stage, so we can subject our sample for the qualitative and quantitative analysis. Again, I am repeating, exploitation, in the prospecting stage. So we did not do any kind of analysis, geochemical or we did not do any kind of geochemical analysis. But in here, during the exploration stage, so we can do some kind of analysis for the qualitative and quantitative estimation of the sample. Qualitative and quantitative estimation of the sample. So we can do chemical analysis. So we can use the metallurgical methods. We can use the X-ray method, spectroscopy analysis, and radiometric methods. So we can use the different kind of methods for the quantitative and qualitative analysis of the particular mineral deposits. Likewise, we can use the AAS, atomic absorption spectrometer, for the geochemical analysis. Also, we can use the UV visible spectrometer for the particular analysis. Even you can use the ICP, AES or OES instrument, inductive coupled plasma instruments. And you can use the SRF analysis, X-ray fluorescence spectroscopy analysis. So you can get some kind of data table like here using the spectroscopy analysis. So based on these data tables, so you can identify some kind of anomalies whether there is some kind of enrichment in the particular mineral deposits, like here, maybe whether barium is enriched or not. So we can determine whether strontium is enriched or not, or whether zinc is enriched or not. So we can determine. So therefore, we can have different kind of geometrical method. Even you can use the SRD, X-ray diffraction analysis, for identify some kind of particular mineral deposit. Actually, it's important to identify the crystallinity of the particular mineral deposit. And you can use the scan electron microscope, SCM analysis, or particle size analysis. And we can use the different kind of geochemical method at the exploration stage to determine the size and the value of the particular mineral deposits. The final target is the exploration stage to calculate tonnage and the grade of the mineral deposits. To calculate tonnage and the grade of the mineral deposits. And the end of this course, I will teach you how to calculate the tonnage and grade of the particular mineral deposits. Actually, I had not enough time in last time mineral exploration and method class. So therefore, I skipped two slides. I need two slides. So at the end of this course, so I will teach you how to calculate tonnage and weight of the mineral deposits. It's really important. So for example, we have to calculate. So this particular mineral deposits has 5 million ton of iron. This mineral deposits has 2 million ton of ilmenite. This mineral deposits has 1 million of rutiles. This minerals has 3 million of calcium carbonate. So likewise, you need to calculate tonnage and the grade of the mineral deposits. So I will teach how to calculate tonnage and grade of the mineral deposits at the end of this course. Actually, in simply, I can briefly outline here is a mathematical calculation. So mathematical resource estimation. And we can use this kind of simple grade system to determine the size and the grade of the deposits. So we will discuss at the end of this course. Okay, again, we are in the exploration stage. So in the exploration stage, and we have to calculate economically recoverable percentage, or otherwise we have to calculate enrichment factor of the ore deposits. How we calculate the enrichment factor? So it's a very easy. I think you have already learned this one in the geochemistry class. This time I did not conduct geochemistry class for your batch, but when I conduct geochemistry class for your super seniors, so I did some continuous assessment to calculate the enrichment factor. I think you also get this kind of examples in your geochemistry class, but I am not sure. And so it's not very difficult, it's very easy. So actually we need the SRF value to calculate the enrichment factor. We need the XRF value to calculate the enrichment value. So here you can see the different sample H1, H2, like H13. So in the here you need the upper continental crust value. At the end of the column, you need the UCC value, upper continental crust value. UCC stand for the upper U for the upper, C for the continental, again C crust, upper continental crust value. So silica has some kind of unique value for the upper continental crust value. So then it's easy. Enrichment factor means, so you have X value, you have upper continental crust value. So divide by the upper continental crust value. So this is your value. This is the upper continental crust value. Maybe imagine this is the sink or the sink. So you have to divide this value, your value, by the upper continental crust value. Based on that one, so you can get some idea about the enrichment factor. Sometimes maybe enrichment factor is about 10. Enrichment factor is about 10. Okay, next time I will show some graph to identify this kind of thing. So enrichment factor 10 means, so this particular minerals 10 times higher than the normal upper continental crust value. So therefore, maybe good anomaly. This is good evidence for the zinc deposit. So therefore, enrichment factor is, so we divide our value by the upper continental crust value. So based on that one, so we can get some idea about the enrichment factor. Enrichment factor is really important to get some idea about the enrichment of the particular minerals based on the upper continental crust value. Please remind me in next lecture. So I will show some kind of real world graph to show some kind of enrichment factor. Okay, in the exploration, and we need to calculate the economic valuability of the ore deposits, and we need to value of our minerals, and we have to determine the level of technology available for the recover of our mineral, and cost of the refining and minerals once recovered, and other macroeconomical factors we have to consider. And then it is important to estimate the mining cost, economically recoverable proportion of the deposits, metallurgical and ore recoverability, markability, and the payability of the ore concentrates. So those things, so we have to calculate the exploration stage. In addition, it is important to estimate engineering concern, milling and infrastructure cost, finance and equity requirements, and analysis of the proposed mine from the initial excavation all way through the reclamation. All things should be we have to consider at the exploration stage. And next stage, so we have to evaluate the financial feasibility, evaluate the technical and land financial risk, and also evaluate the quality strength of the project, and the quality or condition being strong and good condition. So therefore, in summary, I need to highlight that exploration stage is the one of the difficult stage. The reason is we have to do exploration stage very carefully, because so this is our decision making stage. So if our exploration values are wrong, everything will be vanished. That means, so we will take the old decision of the industry based on our interpretation at the exploration stage. Okay, again I am repeating. So we will take all our decision in the industry based on the our final interpretation at the exploration stage. Okay, so again I will back to these few slides. And value of the minerals, yes, we have to define what is the value of the minerals. So whether it's a particular minerals is value or not, we have to define. And level of the technology of the available of the recovered mineral. So we propose some very simple technology to the recover minerals at the initial stage. So we plan everything based on that one. But when we go through the deposits, so we can't use the simple technology. We may need some advanced technology. So then we are failed, because we calculate the old cost considering the primitive technology, but we need advanced technology. Therefore, the cost will be increased. So again, so what will happen? Our profit will be lost. Maybe sometimes expenditure is the higher than the profit if we implement some high technology instrument, and the cost for the refining in the for the refining or recovery, so we have to consider. So we have to define the what is the exact cost. So we have to determine the cost, but our real cost is much higher than our estimation. So then our profit will be lost. Other macroeconomic factors you have to consider. For example, what is the profit we have to consider? What is the profit we have to consider from the particular mineral deposits? We have to consider it. For example, we estimate, so we can get the $5 billion of the particular mineral deposits, and for the expenditure we need to import some machineries to the industry. Maybe dollar value is changed since current situation. So industry is not that safe at anymore, because so all we have to consider considering the today dollar value. So, but if the something is changed, some economic factors are changed in the country. For example, fuel cost is changed. All our estimations are wrong. So therefore, this is a really very difficult thing to determine the exact value for the particular mineral deposit. Even like countries, the foreign investors, they don't like to invest money in countries like Sri Lanka, because the factors like macroeconomic factors are not stable. But when we consider the other developed country, maybe fuel price is the same during the last 5-10 years. Maybe changes is some kind of very sense, very very minor amount. Maybe when compared to the Sri Lankan rupees, maybe price changes may be around within the 5 rupees. Okay, but in Sri Lanka, it's a fluctuates very rapidly and not stable. So these are the not good practices for the bring investors from the foreign countries. And mining cost we have to calculate. For example, if you consider the fuel cost and mining cost can be significantly changed. If you go for the Aruvakkalu deposits, you can see how many fuel they need required for the particular day. They have the separate gasoline station for the particular deposits. That means that they hugely consume the fuel. So therefore, they calculate the whole cost for considering the current factors. So those things we have to think at the exploration stage. Luckily, in the Aruvakkalu deposit, they take calcium carbonate and they use prepare the cement, and we use cement for the local industry. So imagine if we plan to export those cements to the other countries, we can't make a fight with the foreign countries because our production cost is very high. And next, economical recoverable portion of the deposits we have to consider. So we think so we can extract only 10% of the deposits, the raw material from the deposit. But when we are going to the real field, so we can't extract the 10%. We can get only 5%. Then what will happen? Our profit will be lost. So we have to consider those factors at the exploration stage. Markability. So then whether we can sell our products to the market, we have to consider. Other engineering concepts, whether we need some kind of ground support and other things. So we have to determine that the exploration stage. And mining and its infrastructure cost, and we have to determine at the exploration stage. And okay, but from where we have to do the initial excavation? So which direction we have to do our excavation? All things, so we have to consider at the initial stage. Okay, financial feasibility, whether we have enough financial condition to start this deposit, so start the mining work of this deposit. So we have to consider at the exploration stage. And financial risk, so this is the really important. And technical and financial risk, so we have to determine at the exploration stage. Okay, in the exploration, our final target is the reservoir estimation, and we have to estimate the value of the ore deposits. Okay, so considering the reservoir estimation and the value estimation of the particular deposit, so we have to move for the development stage. So the critical stages are exploration and the development stage. Okay, so in the development stage, so we will discuss in detail in next class. Actually, development stage is teaching part is really important, because in the exploration stage, I mentioned different kind of parameters we have to examine. We have to examine. In the development stage, I can simply say we have to confirm what are the exact value. So this is the advanced stage of the exploration stage. So I can simply say this is the advanced stage of the exploration stage. Development stage also same as somewhat same as the exploration stage. So but the difference is, so we have to precisely or accurately interpret things, have to confirm what we derive from the exploration stage. And that's all for today. So if you have any question, you can ask.